Okay, this will be part 2.
So manganese 2-chloride MnCl2 plus NaNH2. But NaNH2 I wrote down solid.
But you have to think about this, though. What happens if you sprinkle solid NaNH2 into an aqueous solution? You have to think of two things. One, will it dissolve? And two, what happens when it dissolves? In other words, first you consider solubility, and then you consider electrolyte properties.
And so let's take a look at sodium amide here. Sodium amide, solid. Is it soluble? Yeah, all group 1 salts are soluble. And so this will dissolve into NaNH2AQ. When it dissolves, is it a strong electrolyte, weak electrolyte, or non-electrolyte? Strong electrolyte because?
It's not adding compound.
Okay, is it a strong electrolyte because it is soluble salt or because it's a strong base?
It's because it's a soluble salt, the electrolyte property. And so it's a strong electrolyte because it's a soluble salt. And therefore, what happens?
It breaks up into sodium ions and amide ions. Minus. So this is usually what we consider. And so even though this says solid, what's going to happen? Well, one, it's going to dissolve and then it's going to ionize. So really I can get rid of this solid and just call it aqueous because the solid should dissolve, or I could write the solid here and then just say, since there's water present, I'm going to have MnCl2 plus NaNH2. Because of the water being present, it should dissolve. And so this is just an AB plus CD reaction, right? And so what should I form? I'm going to form
Manganese 2 amide.
yeah, manganese 2 amide and sodium chloride. So then we ask ourselves the question, do we get a precipitate?
Yeah.
What's the precipitate?
Manganese 2 amide.
Well, did I tell you the solubility rules for amides? What do you think? Are amides, like for example, amide, it's a -1 ion. So we might think of something like chloride. You know, chlorides are typical -1 ion. Is manganese 2 chloride soluble or insoluble? Manganese 2 chloride, bromide, iodide. Soluble or insoluble? Soluble. And so, why do you think this is? Well, why do you think that's insoluble? Amide's kind of a big ion, right? And so, my guess would be it does not precipitate. As I mean, this didn't precipitate, did it? This was soluble, so this is probably not going to precipitate. What about sodium chloride? For sure that's not going to precipitate. And so I'd say there's no precipitate. Is there gas formation? No gas formation. Do we form a stronger acid from a weaker? Do we form a weaker acid from a stronger acid? No. And so here I'd say there's no driving force, therefore no reaction. And again, you want to show the potential products here. But I wouldn't think this would precipitate. Now, if amide was a 2- ion, then I might reconsider a 3- ion for sure. Probably precipitate. But a 1- ion, you think that's going to precipitate? No. Also you can think of nitrates. Nitrates are 1-, all soluble.
chlorates, 1 minus all, and acetates, 1 minus all soluble. And so that's what I get. But, you know, is metathesis the only type of reaction out there? No. And so, actually, that's all I got here. So one person inventoried, but didn't quite finish. Yeah. And so then, maybe I didn't give you enough time. Were you going to inventory it next? What were you going to do?
We thought it was solid.
Okay. You thought it was insoluble? Okay, that's okay. Well, I'll let you know, it is soluble.
So the bigger the negative charge, the more likely it will precipitate.
Yeah, so Raheem said the bigger the negative charge, the more likely it'll precipitate. That's true, right? Remember the pattern that we looked for in the solubility rules? We try to use those patterns to make simple predictions. This would be a simple prediction. You know, it's better if we had the theory, a really good understanding of the theory to make predictions, but we can make predictions based on patterns too. The only caveat there is when you make a prediction based on the pattern, then we don't know all the exceptions to the patterns. You know? So there is a chance that it might be wrong. Well, okay, but you know, metathesis is not the only thing you look for. You also look for acid base. And so let me give you another minute and to figure out the acid base